When studying diffusion and osmosis, you'll be asked to describe movement of a molecule in an experimental setup. Diffusion process is a movement of molecule, and osmosis is used to describe movement of water molecule only, so be careful when you are describing movement of a molecule. Before you start, it is important to know the definition of solute and semi-permeable membrane. Solute is a molecule that dissolves in a solvent, and semi-permeable membrane allows certain molecule to pass through based on their size. In the next slide, I will show a sample experimental setup. In this experimental setup, there is a large beaker filled with water and a small dialysis bag that contains 10% starch and 10% glucose solution, and a glass tubing is inserted into the dialysis bag. To write a good answer, be sure to describe both the concentration and the location. Writing that molecule is moving from high to low, or it will move until equilibrium will reach, are not good answers. Read the question carefully. The question will ask you about specific movement of molecule, and which molecule will and will not pass through the semi-permeable membrane. In this example, I am describing the movement of glucose molecule, and I am stating both glucose concentration and location of molecule. Note that starch molecules are too large to pass through the dialysis bag. After you move all the solute, there will be an equal movement of glucose molecule inside and outside, and the concentration of glucose will become 5% inside and 5% outside. Then, we will move water molecules. When water molecules follow the area of high solute concentration, there is much higher solute concentration inside of the dialysis bag, which is 15% than outside, which contains 5% solute. Note that starch and glucose are both solute, so combined solute concentration 10% and 5% will become 15% in the dialysis bag. As a result, water molecules will enter to the dialysis bag, and it will gain water, so the solution level inside the bag and glass tubing will start to rise.